A swap is a derivative that requires two parties to exchange cash flows from one asset for cash flows from another asset. Let's look at how this applies when interest rate swaps are used to convert a fixed rate exposure into a floating rate. Consider an Australian organization that has an existing borrowing of $5 million with 3 years to maturity. The interest rate on the loan is fixed at 5% per annum, with interest payable annually in arrears. The organization wants to convert its fixed rate borrowing into a floating rate borrowing and decides to enter a pay floating, receive fixed interest rate swap to achieve the desired result. The IRS is entered into with a counterparty, usually a financial institution providing a floating rate of BBSW and a fixed rate of 4.5% on a principal amount of $5 million with annual settlements for a period of 3 years. Note that the 0.5% difference between the fixed rate of 5% charged on the borrowing and the fixed rate of 4.5% on the IRS represents the credit margin charged by the bank on the borrowing and is not included in the swap arrangement. In the IRS, the principal amount of $5 million is never swapped. Only the net interest differential between the BBSW at each settlement date and the swap fixed rate of 4.5% is swapped. As the organization is paying the floating rate on the IRS, if the BBSW is higher than 4.5%, the organization pays the net interest differential to the counterparty. If the BBSW equals 4.5%, no cash flows are exchanged. If the BBSW is lower than 4.5%, the organization receives the net interest differential from the counterparty. The cash flows can be summarized as follows. The fixed rate borrowing is at 5%. The swap payoff or floating rate pair is calculated as 4.5% less the BBSW. The hedged position is therefore the BBSW and the fixed rate differential. Note that the hedged position shows a cash outflow and the 0.5% fixed rate differential, which increases the amount of that cash outflow. Assuming the following BBSW rates at each settlement date, we can ascertain the actual rate of the hedged position. Assume the actual BBSW rates in years 1, 2, and 3 are 4, 5, and 6% respectively. The hedged position for years 1, 2, and 3 will therefore be 4.5, 5.5, and 6.5% respectively. We can then calculate all interest amounts and determine the actual cash flows that take place as shown in the table. Item 1 is the floating rate pair and is calculated as the principal amount of $5 million times the actual BBSW rates. Item 2 is a fixed rate receiver and is calculated as the principal amount of $5 million times the swap fixed rate of 4.5%. Item 3 is the net interest differential and represents the actual cash payment or receipt on the swap and is calculated as item 1 plus item 2. Item 4 is a fixed rate borrowing and represents the actual cash payment on the existing borrowing and is calculated as $5 million times the fixed rate of 5%. Item 5 is the hedged position, which nets the swap payment or receipt with the cash payment on the borrowing and is calculated as item 3 plus item 4. To recap, an interest rate swap can be used to eliminate a fixed rate exposure. The net effect of such a swap arrangement is that the company will have a hedged net exposure that moves in line with the changes in the reference rate.